Hello, my dear children. In the polynomials chapter, in the exercise 2.4, we are going to discuss these points. What are the points? Factorization of polynomials. In this exercise 2.3, some polynomials will be given. We have to factorize. Here there are two methods. We discuss here two methods to factorize a polynomial. The first method is factorizing by using factor theorem. We use a factor theorem to factorize a polynomial. Okay, my dear children. And second one, factorizing a quadratic polynomial. This is a special case. If a quadratic polynomial is given, what is meant by quadratic polynomial? The degree of a polynomial is 2. In that case, factorizing a quadratic polynomial by splitting the middle term method. We use this splitting the middle term method to factorize a quadratic polynomial. Okay, my dear children, are you ready to learn these points well? Okay, right. Before going to discuss factorizing a polynomial by a factor theorem, let us know what is meant by a factor theorem. Okay, my dear children, see, this is a statement of a factor theorem. If P of X is a polynomial, of degree n greater than or equal to 1, and A is any real number, then x minus a is a factor of P of X. If P of A is equal to 0. And second one, P of A is equal to 0 if x minus a is a factor of P of X. That is, we can join these two statements as a single statement. We can write as a single statement. See here, x minus a is a factor of P of X. If it happens, automatically this also happens. That means P of A is equal to 0. Similarly, if P of A is equal to 0, then we can say that x minus a is a factor of P of X. Understood this statement, my dear children? This is a statement of a factor theorem. I repeat this one, x minus a is a factor of P of X, then P of A is equal to 0. If P of A is equal to 0, then we can say that x minus a is a factor of P of X. This factor theorem actually follows immediately from the remainder theorem. This is the continuation of the remainder theorem. In the remainder theorem, we have found the remainder. If the remainder is 0, this is a remainder. If the remainder is 0, then we can say that x minus a is a factor. If x minus a is a factor of P of X, then the remainder is 0. Okay, my dear children, understood this concept? Then we go to example. Let us take an example to understand this factor theorem. Okay, my dear children, right. So to understand the factor theorem, we are taking an example. Okay, my dear children, see example. Examine whether x plus 2 is a factor of x cube plus 3x squared plus 5x plus 6 and of 2x plus 4. Understood the question, my dear children? Here two polynomials are given. This is one polynomial and this is another polynomial. We have to check this polynomial is a factor of this polynomial or not. Similarly, we have to check this x plus 2 is a factor of this polynomial or not. It means there are two parts. Understood the question, my dear children? Read the question well and first understand the question. Okay, my dear children? Right. So let us consider this polynomial is p of x. We assume that given polynomial is p of x. So therefore p of x is equal to x cube plus 3x square plus 5x plus 6. Understood this step, my dear children? Here we are assuming the given polynomial is p of x. They have not given this one p of x is equal to. We are assuming here. We are considering here. Okay, my dear children? Now, what is the polynomial here given? X plus 2. So let us find 0 of this x plus 2. You know how to find 0 of a linear polynomial. How do you find 0 of a linear polynomial? We have to equate the linear polynomial to 0. So x plus 2 is equal to 0. So we get an equation in x. We solve it. X plus 2 is equal to 0. If you move plus 2 to RHS, then it becomes minus 2. So x is equal to minus 2. We got the value of x, that is x is equal to minus 2. Okay, my dear children, this number is said to be 0 of the polynomial x plus 2. 0 of the linear polynomial x plus 2. We found here 0 of the linear polynomial. Now we have to substitute this number. We have to substitute this value in the p of x in the given polynomial. That is p of minus 2 is equal to minus 2 whole cube plus 3 into minus 2 whole square plus 5 into minus 2 plus 6. Understood this step, my dear children? Just we are substituting x is equal to minus 2 in the given polynomial. Understood this step, my dear children? Right. Now in RHS there are 1, 2, 3, 4. 4 terms are there. So a small technique, a small trick is there. What is the small technique? What is the small trick? We have to find the value of each and every term separately in rough work. In rough work, find out the value of each and every term separately. After that we join them. After that we add them. Understood, my dear children? Then what is the first term? Minus 2 whole cube. So here see in rough work I am doing here minus 2 whole cube. What is meant by minus 2 whole cube? Minus 2 into minus 2 into minus 2. Isn't it, my dear children? Right. So what will you get here? Minus into minus plus, plus into minus minus. So finally we get a minus. We get a sign minus. After that numerical value 2 into 2 4, 4 into 2 8. So finally we get here minus 8. Minus 2 whole cube value is minus 8. That is the value of the first term. Understood this part, my dear children? Right. Now come to the second term. 3 into minus 2 whole square. I wrote here 3 into minus 2 whole square. I am also finding here the value of the second term separately. So 3 into minus 2 whole square means minus 2 into minus 2. Do you remember this one? How to write minus 2 whole square, my dear children? Right. So understood this one? Right. So plus into minus, minus, minus into minus, plus. So finally we get here plus. So I am not writing plus sign. After that we multiply numerical values. 3 into 2, 6, 6 into 2, 12. So finally the value of the second term is 12. Understood, my dear children? Right. Now come to the third term. What is the third term? 5 into minus 2. 5 into minus 2. So plus into minus. What will you get here? Sign minus. After that multiply the numerical values. 5 into 2. What will you get here? 10. So in the rougher I found the values of the each and every term separately. Then we join them. We add them. So minus 8 plus 12 minus 10. We write one after the another term. After that last constant term is there, I am writing that constant also. Understood this step, my dear children? Right. Now we have to simplify these four numbers. In these four numbers, there are positive numbers also there, negative numbers also there. So first we add all positive numbers. What are the positive numbers here? Plus 12 and plus 6. By adding these two numbers, what will you get here? 18. After that, we have to add all negative numbers. What are negative numbers here? Minus 8, minus 10. These two are negative numbers. So add these two numbers. 8 plus 10. What will you get? 18. So minus. Because these two numbers are minus. So minus 18. Understood this step, my dear children? Right. Then we have to simplify these two numbers. 18 minus 18. What will you get here? 0. So this is the remainder we got here. P of minus 2 is equal to 0. This is nothing but the remainder when this polynomial is divided by this polynomial x plus 2. Understood this point, my dear children? Right. So here we got remainder 0. So by factor theorem, we can say that x plus 2 is a factor of x cube plus 3x squared plus 5x plus 6. Understood this first part of the question, my dear children? Right. Now let us take an example, second part of this example. What is the second part of the example? We have to check, we have to examine whether this polynomial x plus 2 is a factor of second polynomial, that is 2x plus 4. We follow the same steps as we followed in the case of first polynomial. Like for this one, we follow here also same steps. Let us assume that q of x is equal to 2x plus 4. We are assuming that. Okay, my teacher, we are supposing that the polynomial is q of x. So q of x is equal to 2x plus 4. What is the 0 of this polynomial? Minus 2. We have already found it. That is why I am not finding here again 0 of the polynomial. Okay, so put x is equal to minus 2 in q of x. We are substituting x is equal to minus 2 in q of x. What does it mean? We are finding the remainder. Understood, my dear children? Here we are finding the remainder. Then what will you get here? Q of 0. Q of minus 2. Q of minus 2. We are substituting x is equal to minus 2. So q of minus 2, q of x is there. So q of minus 2 is equal to 2x. 2 into x means minus 2 plus 4. Understood this step, my children? Just we have substituted x is equal to minus 2 in this polynomial q of x. Understood this step, my children? Right. How many terms are there? Only 2 terms. 2 into minus 2 is 1 term, plus 4 is another term. Let us simplify each and every term separately. I told you in the previous part of this example. The simple technique is we have to simplify each and every term separately. Here these are 2 terms. This is already constant. We can write it plus 4. Then we are simplifying this first term. 2 into minus 2. What will you get here? Minus 4. That is why I am not doing here rough work to find the value of this term separately. Understood, my dear children? Right. So the value of this first term is minus 4 and we wrote the second term as it is, that is plus 4. Understood this step, my dear children? Right. Now we simplify these 2 terms. Minus 4 plus 4. What will you get here? The 2 terms gets cancelled. Finally we get here 0. It means we got here remainder 0 when this polynomial is divided by x plus 2. Understood, my dear children? Right. So by the factor theorem, x plus 2 is said to be a factor of 2x plus 4. Understood this point, my dear children? Right. Now let us take another example which is based on the factor theorem. Okay, my dear children? Right. Example 2. Find the value of k. Find the value of k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k. Understood the question, my dear children? Read the question well. Read the question number of times until you get meaning of the question, until you understand the question well. Otherwise, you can't solve it right. Okay, my dear children? Right. Now, here in this question, they did not use the word factor theorem, but the question is based on the factor theorem only. That is why I am telling you, read the question number of times. The question is based on the concept of factor theorem. Okay, my children. So let us consider the given polynomial is p of x. So let p of x is equal to 4x cube plus 3x square minus 4x plus k. We are assuming the given polynomial is p of x. Understood that step, my dear children? Right. What is given here? X minus 1. X minus 1 is a factor of p of x. It is given in the question itself. X minus 1 is a factor of p of x. So let us find 0 of x minus 1. We are finding 0 of x minus 1. This is a procedure. X minus 1 is equal to 0. We have to write this equation. Given linear polynomial is equal to 0. Then we get 0 of that polynomial. This implies x is equal to 1. We have to solve this equation. Understood this step, my dear children? Right. So, what is the value of x here? 1. So, we have to substitute this 1 in this polynomial because factor, it is a factor of p of x. So, by the factor theorem, what can we say? Remainder is 0. This is a remainder. I told you in the previous example also. This is remainder. P of 1 is equal to 0. P of any number, any real number, P of A is said to be remainder. So, P of 1 is equal to 0 because by the factor theorem. Understood this step, my children? They don't give this statement. We have to write by understanding the question well. Okay, my dear children? Right. This implies in the polynomial p of x, we are substituting x is equal to 1. So, 4 into 1 whole cube plus 3 into 1 whole square minus 4 into 1 plus k. In LHS, in the polynomial p of x, we replace x by 1. Then we got LHS part is equal to 0. We write RHS part as it is. Understood this step, my dear children? Right. In LHS, if you observe, there are 4 terms. 1, 2, 3, 4. So let us find the value of each and every term separately in rough work. I told you many times, in simplifying a polynomial, in simplifying an algebraic expression, in finding the value of a polynomial, we have to find the value of each and every term separately in rough work. What is the first term? 4 into 1 whole cube. I wrote here 4 into 1 whole cube. 4 into 1 cube means 1 into 1 into 1. Understood this part, my dear children? Right. Now we have to multiply these numbers. What will you get here finally? 4. So that is the value of the first term. Understood the part, my dear children? Right. Now come to the second term. What is the second term? 3 into 1 whole square. 3 into 1 whole square. So 3 into, what is meant by 1 whole square? 1 into 1. Understood this part, my dear children? Right. Then we have to multiply these 3 numbers. 3 into 1, 3. 3 into 1, 3. So finally we get here 3. That is the value of the second term. Understood this part, my dear children? Right. Now come to the next part. What is the next term? Minus 4 into 1. I wrote here separately. Minus 4 into 1. So minus 4 into 1. What will you get here? Sign minus. Sign is minus. 4 into 1, 4. Understood the part, my dear children? Right. So, these are the values of the first, second and third terms respectively. So, we join them. We add these three terms here. So, 4 plus 3 minus 4, and after that here one more term is there, plus k. I wrote the term also here. Remember that term also, my dear children, in LHS. Understood LHS part, my dear children? Right. Is equal to 0. Understood this step, my dear children? Right. Now 4 minus 4 gets cancelled. What will the terms left here? 3 plus k. Only these two terms will be left here in LHS. Is equal to 0. Understood this step, my dear children? Right. We solve this equation. It means we have to find the value of k. So this implies k is equal to, we move the term 3. We transform this plus 3 to RHS. Then what will you get? Minus 3. So k is equal to minus 3. This is the value of k. If x minus 1 is a factor of this polynomial, then the value of k is minus 3. Understood this, my dear children? Right.